Hi everyone, I've just gone live. So while we wait for people to come on, just making sure it's going. Yeah. So to make sure that you can all see it, can you comment below? So at the top there we've got comment with the time of your local high tide. So hi Lucy. So what we're going to do is I'm going to draw a little map of all the tide times around Britain, all the high tides. And then when we've got a few people on and we've got the tide times, I'm going to introduce myself and I'm going to talk a little bit about the tides. So just while we're waiting for people, comment below, tell the time of your local high tide, and I'll write it up on my board, and then we can start talking. So we've got 7 people looking. So if you're near the coast, type it in, and I'll give it a couple of minutes. So where I am now in Deal, I'm not sure if that's too small to see. High tide was at 4 in the morning and 4:45 this evening. So when we've got all of this information in, we can then get a really good idea of what the tides are doing. So I've got Amy. Hi Amy, you're in Bedford, not sure you have a tide. No, well, where is the local tide to Bedford? Let's, if anybody's nearby, just comment on there. So I'll give it a few minutes. And then we'll see. So in the meantime, I'm going to introduce myself. Hi Matthew, you're in Cromer. What's the tide there? So we've got Cromer is there. So we've got Matthew there. So to introduce myself, what I'm going to talk about today, my name is William Thomson. I'm a tide expert, and this summer I'm going on a sailing trip with my family, my 2 young kids. We're going to hopefully go for 4 years. And we're going to sail all around the world, that's the plan, and we're going to be exploring solutions to rising tides. So what I'm going to talk about today is I'm going to talk a little bit about tips that I've learned about the tides from the Imray Tides Planner. So I'm going to look at 5 tips of what I've learned from the Imrays and how that is going to help people sailing. And I'm also looking for tips from other people who have got experience sailing with kids. So my 2 kids are 3 and 5. They're going to be 3 and 6 when we set sail, and then over the years they're going to get a little bit older, and we're looking for tips on how to keep them safe at sea, how to keep them happy and entertained, and we're going to be boat schooling them as well. So tips on how we can learn through the experience things like maths and English and writing and everything. So if you've been sailing with kids, share your tips, and afterwards I'm going to put together some information useful for other sailors about how to do it. So I've got a couple of comments here below. We've got Lucy is Wales next to sea at 1910 high tide. Is that high tide, Lucy? Write that in there. And we've got hi Dick, we've got hi Will, high water, 17:30 today, North Kent coast. So you've got 17:30 there. Okay, cool. So that's Lucy's telling us we've got 1910 at North Norfolk. So I've drawn this map here, and what we've got is the tides are made by these waves flowing along the coast. So this is going to be the first tip that I've learned from the Imray Tides Planner. So when the peak of one of these waves passes, we get high tide, and when the trough passes, we get low tide. So around Britain, you've got 3 main waves. You've got one that comes in the channel and it travels up the channel like that. So when it's high tide in the Scilly Isles, the peak of the wave is there, and the trough is in Dover. I've actually got David here saying 1850 at North Woolwich. So we've got 1850. Is that, I think that's right, North Woolwich is in the River Thames. So we've got this, when the peak of the tide wave comes in, the peak is in the Scilly Isles and the trough is in the Dover Straits. And over 6 hours, the peak travels up the channel on both sides of the channel into the Dover Straits there. So perpetually this wave is travelling up the channel like that. Hi Arvid, we've got high Will, high tide is at Portsmouth. Let's that. is that now? That probably is around now. Let's write Arvid. So this wave is travelling up the channel, and at the same time you've got a wave that travels down the coast there and then up the coast back there. So this is a wave in the North Sea, and there are technically 3 peaks and 3 troughs of this wave that are perpetually going around the shores. So when there's a peak in Dover, there's also a peak in the north of Scotland and a trough there. So you've got high tide, low tide, high tide. So these waves are made by things called amphidromic systems. I'll draw them out here. That's a really rough drawing, but they're called amphidromic systems. Amphi is from amphitheatre, and as in a round, and dromic means running. So James just said we've got 1706 at Harwich. So about there. 1706. So we're getting a bit of a map of what's happening in the tides around Britain. Oh, there we go. Arvid, 1730 in Portsmouth. 1730. There we go. So these amphidromic systems are like cogs. They spin around and they've got a high point and a low point. And the high point is high tide and the low point is low tide. So if we say this is a high point of this amphidromic system, then the high point is there. The cogs always meet with the high and low points. And then the low will be there, and this one's low will be there. So these cogs are all completely synchronized, and as they spin around, it takes 12 hours for the high point to make one big spin, and as they spin around, they move this tide wave perpetually spinning around the North Sea there. So Dick's telling us that the meeting point of the North Sea tide and channel tides is Dungeness. So it comes a little bit lower into the Dover Straits and up there. I didn't draw that very well. So Joe is 1630 at Deal, which is here. Let's rub that out. So what happens, what's really clever, is that when the tide wave travels up the Dover Straits, when the high point gets here, the high point of this wave gets there at exactly the same point, and they merge together to travel up the North Sea. So there's this perfect synergy between the tides here. And then on this side of the coast, you've got a wave that comes up into the North Sea, like that. And then you've got another one that comes up like that from the Arctic. And the peak of the wave there joins into this one, just like the joining there, and they merge together. So that's a picture of how the tide waves all travel around the British Isles. So that's useful to know, because if you know where the tide is in one place, you can then work it out where it is anywhere else in Britain just by understanding the relationship between the peaks and the troughs. So if I know it's high tide in Deal, it must be low tide in the Scilly Isles, because when the high of the wave is there, the low of the wave is there. I'm trying to match my hands in the camera. So that's an idea of the tide waves. And what helped me with the Imray Tides Planner is when I started learning about this, you can go to the map on the planner and you can look at the tide times around you, and then if you note them down, say you work down the coast, you can see that high tide gets a little bit later as you go down. And then you can even work out the speed of the wave by the time difference between two places. If you work it out with a mass equation, speed equals distance over time, then you can work out the speed of the wave. So around the North Sea, it averages around 100 kilometers an hour, and the same as in the Channel. But in a deep ocean like the Atlantic Ocean, you've got one big amphidromic system in the Atlantic, and that's travelling at about 1,000 kilometers an hour. So that is because the speed a wave travels is in relation to the depth of the water. So there's a mathematical equation where if you know the depth, you can work out the speed of the wave. So I'm going to rub this out now. There we go. And if anybody's got any questions about how the tides work, just comment below. I haven't rubbed it out very well, but that's okay. So the next thing that I've learned from the Imray Tides Planner is the tidal currents. So anybody who's been sailing is well aware of the tidal streams around Britain and how they're really strong. And on the Imray Tides Planner, you can actually go onto a page and it will show you all the arrows representing the tidal currents at any one time, and then you can go plus or minus hours. So if you press plus hours, you can see as time changes the currents speed up and slow down. So as a general rule, if you're on an open coast, the currents will speed up for 6 hours. Sorry, they'll flow one way for 6 hours and they'll flow the other way for 6 hours. So they speed up for 3 hours and then slow down for 3 hours, and they turn around when they're slowest, that's slack water, and they flow the opposite way, speed up for 3 hours and then slow down for 3 hours. Mm-hmm. So what makes this happen is the tide wave. They're directly connected to the tide wave. So if I do a little sketch here showing the tide wave, there we go, make it a bit further. So this is the coastline. Got a house there, and we've got a house there. So this is the peak of the wave and it's high tide. This is the trough of the wave and it's low tide. So that distance is probably about 600 kilometers. So when you're at high tide, the wave is traveling this way. So the wave is traveling this way, and at high tide, the currents in the wave are travelling the same direction. So if you go sailing there, the current's going to take you that way. But at low tide, the currents are flowing in the opposite direction. So even though the energy in the tide wave is travelling this way, at high tide, the current's going with the wave, and at low tide, they're going against it. So if you know where you are in Britain, and you know which way the tide wave is going, then you can work out, if it's high or low tide, you can quickly work out what way the currents are probably going. But this is quite a complicated process to understand, really, because you've got the energy going one way and the water particles going both ways. So an analogy which really helps to understand how it works is if you imagine there's a tsunami coming. So one of the clues of a tsunami is that you're standing at the beach and all the water suddenly drains out. And that's quite common in tsunamis all around the world. And what's happened is that the trough of that tidal wave has arrived. So even though the tsunami is travelling towards you, when you're in the trough, all the water is being sucked towards the peak. So the energy is travelling towards you, but the water particles within the wave are being sucked that way. But then 5 minutes later, the peak arrives and the water particles in the wave go with it and it surges forward. So with a tsunami, the wave is coming towards you, but with a tidal wave, the waves are going along the coast. So here, the water is being surged along with the wave, whereas here at low tide, the water particles are being sucked towards the peak of the wave here. So if you understand that cycle of currents, you can plan your sails to make the most of them, because around Britain, when it's maximum speed, it averages maybe 3 or 4 knots sometimes in the English Channel. So that gives you that extra speed if you're sailing, or sometimes if you're sailing into the current, completely takes away all your speed together. So with the Imray Tides Planner, you can see what the currents are doing every hour, and this explains why it's happening. So I'll rub this out and we'll get to our next illustration. So if we've got any sailors out there who have got experience with kids, comment below on a couple of tips of how to keep them happy and safe, and I'm going to publish something on the website afterwards to help other sailors. So the third thing, little tidal tips to help you with the tides, is the tide times. So every day the tides are about 50 minutes later. So on the Imray Tides Planner, you've got that lovely graph that shows the tides going through. And if you look at it every morning, you'll notice that the peak of the graph moves along a little bit. Hold on, I'm just looking. So Paul has just asked a question. He said, I'm just clicking see more. Doesn't the direction of the tidal flow generally flow fastest at mid-tide, and slack tide is usually at high and low water? Yeah, so that's a really common misconception on an open coast, is that when your motorboaters watching as well. Okay, thanks, Kevin. So when you're in a river, as a general rule, slack water is around high tide and low tide, and as the tide is rising in the river, the currents flow up, and when the tide is falling, the currents flow out to sea. But on an open coast, it's actually slack water is about 2 hours before high tide, between 2 and 3 hours before high tide, and then when it's high tide, or maybe 1 hour after high tide, that's actually when the currents are flowing their fastest along the coast. So that's the misconception. People think at high tide that's slack water, but actually the currents are flowing fastest in the direction the tide wave is travelling. So if you're on the east coast of Britain at high tide or 1 hour after, the current's going to be flowing south at their maximum speed, because that's the direction the wave is travelling. So Paul says, that's fascinating, never seen the relation between direction of tidal wave and direction of stream explained in any of my sailing books or courses. Yeah, so that's the thing, Paul, is that it helps if you understand why something's happening. It really helps you understand and predict why the currents are doing it. So if you've got any questions, fire away and I'll answer them. So I'm just going to quickly talk about the tide times and why they are different every day. So we've got not a very good circle. So we've got, this is the Earth and this is the Sun. So that's nighttime. So once a day, the Earth is spinning on its axis this way. Let's draw that picture. So once a day, the Earth, or where you are on the Earth, makes a whole rotation around, and 24 hours later you get back to the same point. And that's a solar day. And while this is happening, the moon is also orbiting around the Earth. So the concept of a lunar day is it's when your position realigns with the moon. So if we now draw, sorry, that's completely out of scale pretty much. So today the moon is here. That's the alignment of the sun, the Earth and the moon in relation to each other today. So we pass this point. If you make a line between the centre of the Earth to the moon, so you pass it and then you make your full rotation in 24 hours, but then in the time that you've got back to the same point, the moon has made a 12-degree orbit and it's now here. So to complete that tidal day, it takes 50 minutes to orbit to the new point where you're in line with the moon. And that's why tides are 50 minutes later every day. The tidal day is 24 hours and 50 minutes. So it's because the moon is orbiting that little bit every day. So the 50 minutes is the time it takes to realign. So we'll rub that out. So every, because the tide waves are determined by the moon phase, at each moon phase, so when the moon is there, the peaks of the tide wave will always pass your local beach at exactly the same time. So the control of the moon over the tides is within about half an hour of a set time. You can be sure that you'll get high tide when the moon is like that. And then every day later, it's 50 minutes. So where I am in Deal, on the new moon, high tide is around midday. So about 11:30, 11:45. So if you say it's at midday, and then every day later it's 50 minutes, and that adds 6 hours over a week. So if high tide is at midday then, it's at 6 o'clock then and then midday again here. And because you get spring tides on the new moon and the full moon, basically the high tide times are the same every spring tide, because over a fortnight it adds 12 hours. And then over a whole month it adds 24 hours, and you're back to the same time. So if you learn your local high tide time for the new moon, you can then use that 50-minute concept to work out what the tide is any day of the month just by observing the moon phase. So rub that out. Okay. So I'll just put that. I've got some notes here to remind me what I'm going to talk about. So it's 20 past. So if anybody's got any questions, just ping below. I've got 2 more topics to talk about that I've learnt from the Imray Tides Planner. And the first one is about the moon rising. So when I started doing all my water sports and things, I didn't really pay much attention to the moon. But then on the Tides Planner, you've got a little at the bottom, it tells you what time the moon rise and set is every day. And I noticed that it was changing about 50 minutes later every day, same as the tide times. So I did some little sketches like this one here, and I worked out why the moon is rising like that. And if you understand why that's happening, it's really useful for your adventures for 3 main reasons. Firstly, it's good for navigation. So the moon generally rises in the east, it culminates, so it's in the highest in the sky, about due south, and then it sets in the west. So if you know what kind of time the moon's going to rise or set, you can work out what direction you're facing. The second thing is, if you know when the moon's going to be in the sky, you can then look at it, and if you can see what phase it is, you can work out what the tide times are. And then the third one is that from the moon phase, you can work out whether it springs or neaps. So for a lot of sailors around Britain, spring tides is when you've got more hazards. You've got tidal bores in some of the rivers, you've got whirlpools, or you've got the tidal races. So observing the moon phase is useful in all kinds of sailing. It's got multiple benefits. So to quickly explain how you can predict the moon rise as approximate rule, we've got this setting here, so I've shaded that out because as the Earth orbits around, basically this side is at night time because the sun's rays are only reaching there. So we'll draw this line. Draw some lines there. So as you, let's say you're here, and then as the Earth spins around, you're going to night time, and then it's midnight there, and then you're coming around and it's early morning, and then when you're about here, you get sunrise. So that's when the sun's rays are just visible to the east. And then you continue around, and then when you're directly in line, a line between the North Pole, the poles, and your position in the sun, that's when it's highest in the sky. The sun is highest in the sky, it's local noon, and the sun is due south when you're North Hemisphere. And then as you continue around, the sun starts lower, and then when you're here, you lose the sun's rays and it's on the western horizon. So that's the concept of the sun's rays rising and setting. Now when the moon is here, it's the same concept. So if I draw these dashed lines there. So as you orbit around, so when you're here, you can't see the moon, so it's not in the sky. And as you come around midday, that's when you start seeing the moon's rays. So on this moon phase, which is the first quarter, the moon rises about midday, and then as you come around it gets higher in the sky, and just as the sun's setting, if it was the equinox, so about 6 in the evening, that's when the moon is highest in the sky, it's due south. And then as you come around it starts setting in the west, and then you lose it. So that's the concept of the moon rise and moon set. So the first quarter moon phase rises around the middle of the day, and then it sets around midnight. Whereas here, the third quarter moon phase, draw these lines again, that's the opposite. It rises about midnight is when you first see it, and then it culminates, so it's south in the early morning, and then it sets around midday. And then the full moon so the full moon there, the full moon rises about 6ish, so when you lose the sun's rays, and then you see it all through the night, and then you lose it in the early morning. So that little diagram explains it. So if you're planning a passage and you want some moonlight early in the evening, then you ideally want to go for a moon phase when the moon is between here and there, because you're going to get the moonlight through the night. Whereas in the early night, whereas on this phase, you don't get the moonrise till midnight. So if you wanted to leave really early in the morning before sunrise, you could go on the third quarter and you've got the moon high in the sky very early in the morning before sunrise. So understanding that can help plan your passages and make for much safer night passages. So I'm going to rub this out now. Okay, so I've got one more thing that I've learned from the Imray Tides Planner, and that is that the tides are never ever what they're astronomically predicted, and that's because the weather has a massive effect on the tide. So you can look at your app or whatever you use, and it says high tide is at midday, but it never will be. Or if it tells you that high tide is 5 meters, it's never 5 meters. And that's because the wind and the air pressure have a huge effect. So if I do a little sketch, I'm going to use some different colours. So I've got two sort of situations here. So you've got a sea wall and then you've got the sea. So let's say on this day, this was the predicted tide height. That was the predicted high tide. So if you've got low air pressure, so this is high air pressure, this side is going to be high pressure. So you've got cold air is sinking, this is high pressure, and that's synonymous with clear blue skies and sunshine. The pressure is literally pushing the sea down, and the tide is going to be lower than astronomically predicted. And if at the same time you've got offshore winds, these winds here are literally going to push the sea even more further out. So this is actually what's going to end up as your tide. So high pressure and offshore winds are going to bring you down from your predicted height to your actual height here. And then in contrast, if you've got low pressure, which is typically hot air rising, creates low pressure, that literally brings up the sea 1 centimetre for every millibar drop of pressure. So the sea will go up for every millibar. Now if at the same time you've got onshore winds, let's say the pressure brings you up that far, so 5 centimetres for 5 millibars. And then the onshore wind is literally going to blow the water even higher, so you end up with a tide like that. I'm drawing it without looking. Let's see, is that any good? It's okay. So your tide you're predicted on the app is this middle dotted line, but actually the weather can change from the tide being all the way up here to the tide being all the way down there. So you want to look at your tide app, and then you also want to look, I use the windy app, and that's really good. You can set it so it shows you both the pressure and the wind direction together. So that's the effects of wind and air pressure on the tide. Got a couple of comments here. Sat watching whilst looking at the first quarter moon almost due south in England. Yep, so that's exactly, so it's about 6 o'clock in the evening, so, and it's the first quarter moon phase tomorrow, so yep, it should be due south around now, so that's perfect. So Jackie says, hi, Jackie from the Sailboat Project, going to share to our Facebook page. Thank you, Jackie. Matthew says, keeping kids entertained, get them involved, give them jobs and titles. Kids respond great to this. So chief engineer, yep. I'm just pressing Seymour. First mate Arva. Keep passage relatively short with plenty of stop-offs. Maybe your children could write their own shipmate's log. Yep, that's a really good idea. I was thinking actually sailing master Arva because he's the boy, and first mate Ottilie, but we do need a chief engineer because I'm hopeless at mechanics. So we're going to finish off with one last thing. What's the time? It's 6:30 now. So we're just going to finish off with a little bit about how the wind affects the currents. So I'm going to draw a map of the coastline. Let's fill that in. Where's the... It's really crappy. So that is the land. It's not a very good drawing. So the tidal streams are flowing this way. And if the wind is also flowing that way, what's going to happen is the sea is going to be much calmer, so it's going to be a nice calm sea because the currents and the wind are both blowing together. But also, crucially, slack water is going to be an hour later if there's a strong wind with than what's predicted, because the main currents are all flowing that way, but the wind is driving a surface current. So if your tides planner says high tide is at 10 AM on this day, sorry, slack water is at 10 AM that day, then actually you want to bear in mind that it's probably going to be at 11 AM. So it can be an hour difference. So I've gone swimming before at slack water, or when it says it should be slack water, and actually I've been pushed along the coast, and that's because the effect of the wind and the current together. However, if you've got the current going this way and then the wind is now going that way, what you end up with is they can both be travelling at the same speed as they were before, but because they're going into each other, you're going to have much steeper seas. You can have this really horrible little sort of they were just sort of crashing into each other. It gets really choppy, very small chop. And the other thing is that, let's say slack water is going to be at 10 AM again. So slack water was going to be at 10, but actually because the surface water's flowing this way, it's probably actually going to be at 9 AM. So the water at the surface is going to turn the slack earlier. So if you're aware of this concept, it means that you don't treat slack water as this set thing. So instead, you can maybe leave an hour earlier if you know the current's going to turn an hour earlier, and you're going to have the currents with you, so it can increase the time that you can sail with it. So I've just got a couple of comments here. I've got to click see more. So we've got so many sailors I talk to think the tide is gospel. They cannot grasp that the times are merely predicted and almost never work out that way. That's exactly right, Dick. And then Neil Gordon, standard pressure is 1020, so 1 centimetre per millibar higher or lower than this. I think it's 1013.2 is the average, but so about 1013. So Ind Perfect says, I sail the Solent, love the Solent wind over tide chop. It's not very nice when you're swimming, because when you're trying to do front crawling, you take the breath and you just get this little wave in your face. So if you want nice calm conditions, you want to time it for when you've got the wind and the currents together. So it's 1833. If anybody's got any questions, I'm going to log off in a minute. So ask any questions below or comment below. Kevin, can we follow your cruise? Yes, we're going to be mostly posting on Instagram, I think. It's at Tidal Compass is the page. We've got a drone, so we're going to hopefully take some really nice shots of the boat in lots of sailing destinations, and I'm going to be doing a little Instagram story in the mornings just to sort of talk about what we're up to and where we're going. Anne Chiver says, can I watch this again? Yes, if I press the right buttons, then we will be saving it onto the Imray page. So I'm going to... Polar Steps is really good. Okay, thanks Warren. Okay, so I'm going to log off now. You can comment under the video on the actual Imray page, and we can answer if anybody's got any more questions or anything they think about over the next couple of hours, and I can answer any questions you ask. So I'm going to log out now. Thanks for watching, and I hope you enjoyed it and learned something new.